much, Christopher, for that introduction. Hopefully my audio is coming in clear at this point. So my name is Paul Taubman with 9.Connects, and I'm going to flip over the screen over here just to make sure you guys can see it. So hopefully it's being broadcasted over here to you. What this is not going to be is an electrical tool demonstration. So I want to put that straight off there. I know you just came back from lunch. I know you can easily get into a food coma, and this is not necessarily your domain. I'm fairly certain that I'm talking to a number of mechanical folks and not electrical folks, and so we get that here at 9.Connects. So what I want to do instead is I want to talk a little bit about why you should even care about electronics. So those are my objectives. Why should you care about electronics? And secondly, if you do care, how do you get involved with it, especially if you don't have a whole lot of background in it? And then that will kind of dovetail into who we are here at 9.Connects. So the big buzzword out there today is this thing called artificial intelligence. And if you really think about it too, you keep hearing IoT as well, but that really is kind of a subtopic of artificial intelligence itself. And it's not just human-looking robots. So I think if you see that picture up there, I think we all want one of those robots that can clean the house for us so we don't have to do that on a Saturday morning. But it really has to come down to just any appliance that you've got being smart enough to provide intelligent information or to do intelligent things for you. So a lot of our appliances that are coming out there today are starting to have this, what they call smart capabilities in them that they never had before. So they can help us prepare for things, they can help us schedule things, they can tell us if something is missing, and so on and so forth. So it's not just a humanoid looking robot, it's any product that has to have intelligence. So what does this intelligence require? Well, there's really three requirements if you boil it down. The first requirement is just simply intelligence. But this is really something we've been doing for the last 50 years. We've been teaching, we've been writing programs for things to learn, right? So it doesn't always have to start from square one. Every single time you turn it on or every single time you execute the program, it can look at what's been done before so it can pick up where it left off, right? Those are the kind of things that we want, because it's kind of frustrating to do the same thing 50 times and you're saying to yourself, man, it'd just be nice if it just learned it the first time or the first couple of times. So we are seeing those capabilities come more and more, not just in our products, but even in our programming capabilities as well. There has to be reference of information, so these things have intelligence to look at something. It doesn't have to try to rediscover it every single time. And of course, obviously, recall capabilities. So if you got a big old database sitting somewhere, but you can't recall from it, then that's kind of a useless database. So it's all there. The cool part is that it's getting faster, and it's getting, with all the complexity of the transistors and the chips that they're putting out, it's just becoming faster and better all the time. As a side note, if you look at the Apple and AMD, they're both vying for the largest chips, okay? And those chips are basically over 5 billion. I think now they're at 5 billion transistors, right? I mean, and they're trying to put more and more transistors into these chips all the time so they can give you more and more intelligence and functionality. The second requirement are the sensors. And these sensors are becoming plentiful, they're becoming cheaper, and they're coming a whole lot better. Think about the camera in your phone, right? Do you remember about 20 years ago, there'd be a 4 megapixel device out there, and the next thing would come out as a 5 megapixel device, and they keep one-upping themselves. Well, you don't even hear about that anymore, because any camera you buy ought to be just really good, almost as good as an analog camera at this point. And they're super cheap too. And if you think about it even more so, everyone's pretty much got a camera in their pocket, which was kind of unheard of even let's say 25 years ago. So there's cameras everywhere, because why? They're a sensor and they're cheap and they're getting better and better all the time. And this is true with a lot of other sensors. But the one key thing with artificial intelligence is it can't sense something, it can't do any intelligent work on it. So give you a great example, like a washing machine, it actually tries to sense in order to balance the load before it starts. We don't have to do that manually anymore. You just throw it in and it tries to figure out how to balance it. That has to be done through sensors. So the idea behind that is that you just need to get more and more sensors on there. Fortunately, they're getting cheaper, and fortunately, they're getting a lot better. The third thing is just the ability to communicate. And we've been doing this with machines for, again, 50 years plus, where we are typing in things directly into the computer. We still do that, but now, to be quite honest with you, a lot of times I just dictate both my emails and my text into my smartphone. So I don't even have to type anymore if I really don't want to. So we have the ability to talk with our machines, literally. We have our ability to use smart devices to talk to our machines, and these machines are capable of talking to each other. So the communication capabilities out there are just far and wide. So what does that mean? What that means is that it's getting easier and easier to put electronics into classic mechanical items. So here's a couple of examples for you. If you've gone into any restrooms, especially at a company or an airport, what do they have? They have touch-free faucets. You don't have to turn any spigots on anymore. In fact, sometimes you go into a restroom of a restaurant and they haven't upgraded it yet, and someone washed their hands and forgot to turn the spigot off because they're so used to these touch systems there, so you have to turn it off for them. But there's also things like the barcoder. In the past, I remember people walking through these warehouses with just clipboards with hundreds of sheets of paper to try to check off boxes or try to figure out the quantities of things that they had. Now they walk around pretty much with this gun, just hitting barcodes all day just to get the inventory stuff all set to go. And then even your doorbell, which is just nothing more than a chime in the past, now it is a speaker. Now it is it's a camera, and you can talk to the person that's at your front door from a country away, right? That's all you need to do, because we have the communication capability set up so that it can broadcast to your phone no matter where you are. So these classic mechanical devices are now becoming very much electrically oriented as well. Now, the other area where this is really important is in the medical area, and I think this is a really good thing, because classic devices like defibrillators and EpiPens are mechanical devices and they can save lives, but they're only as good as the first responder who is able to use them. Well, who's the first responder? Well, a lot of times that's just you and me. And if we haven't been trained in these things, this can be really, really daunting. So here's another really great example of how you can put electronics into mechanical items. And let me go a little bit more into the EpiPen. It's kind of an interesting thing to me because my son does have a peanut allergy. We do have to keep these around. And when we first got the EpiPens, they give you what's called a trainer. So why do they give you a trainer? Because again, if my son goes into anaphylactic shock, well, the first responder will probably be me. It's going to be in just as much of a panic as the person who's going to anaphylactic shock. So you have to use the trainer to learn how to use this. And I've used it many times. I have it at my desk. It's kind of almost like a fidget toy to me. But to use this thing, you have to know to pull the top off and then basically jam this thing into the person's thigh. And yes, there are instructions here, but the intention of the trainer was only to make sure that in the event of emergency, you already knew how to use it. Because again, when you're in a panic mode, this is not going to be readable to you. You're just not going to be able to interpret that information. So how do they make it better? Well, these new two devices that you see over here are actually talking devices. When you pull the top off, it will explain to you exactly what you need to do. It'll walk you through step by step. And so there again, you have electronics being put into a classic mechanical device that in a situation of this nature will help out tremendously. So it will be inserted and it will be used properly, and a life will hopefully be saved at that point in time. So how do you get involved? If you like what you see and you've heard this stuff saying, yeah, we probably need to get some IoT or artificial intelligence or just any type of electronics into our devices, how do we do that? Well, the big thing we got to understand is there's this thing called the printed circuit board. And the reason why the printed circuit board is so important is because it is what you call the medium of all electronic mediums. So let me bring you to this next slide over here. In this slide, these are all the different types of what you call electrical engineering fields. So you have RF, you have what they call ASICs or computer chips, you have fiber optics, you have systems, and it goes on and on. At the end of the day, I don't care which one of these fields you get into. If you want real hardware, it's going to end up on a printed circuit board, because it's the printed circuit board is going to take all of that stuff that you've put together, whether it's the RF or the ASICs or the computer chips, whatever they are, that's what's going to tie it all together so they can communicate with each other. So with very few exceptions, really PCBs are in all electronics. If you look around you, you're seeing them in every electronic there. Even the light bulbs, if you look at an LED light bulb, what are they sticking it on? They're basically taking that LED, which is a little component, and they're sticking it on a printed circuit board. And usually on the other side of it, they've got a little regulator to convert AC to DC. So even our light bulbs have got printed circuit boards now. So for those in a company that have an electrical staff, and I see this happen all too often, is you have a company and you've got a mechanical staff and you have electrical staff, and they don't talk to each other because basically the matrix or the job things are broken up into different departments. The big thing is you got to talk to the electrical folks. And the reason why is because all too often they do things that probably irritate you to no end. But it's not because they're trying to irritate you to no end, it's just because they really don't know. So I'm going to let you in on two secrets. The first secret is that electrical engineers know nothing about mechanical. And I am an electrical engineer, degreed electrical engineer. I can tell you we're taught nothing on the mechanical side. Number two, as an electrical engineer, they taught me nothing about printed circuit boards, and quite frankly, none of the electrical engineers out there today have come out with a degree where they were taught printed circuit boards. Pretty much none of them. And if they did, they may have taken a side elective class if they even offered it. So those are the two things you got to keep in mind. So a lot of these guys who are doing, and gals who are doing these printed circuit boards have had to learn through industry experience, right, through trial and error. So they're trying to learn this art just as much as the next person is. So I really encourage you to talk to them, because the printed circuit board is very much an electromechanical device. So there's a mechanical element of it as well. And they may be doing things that are driving you crazy, but they're doing it out of ignorance. And if you show them what you're looking for, they'll be more than happy to oblige. So I think that's really what's key over there. The second part of it is collaboration, because you're obviously using tools that are much different from the electrical folks. And the cool part is that collaboration has been very doable, and it's been very doable for the last 10 years, but it's gotten even better now, especially if you're using SolidWorks. I told you I was not going to do a tool demonstration today. These are the only two pictures I'm going to show you. If you have SolidWorks PCB and you have SolidWorks CAD, which you guys just call SolidWorks, you can actually push this printed circuit board back and forth to each other without any import, without any export, without messing with any steps, and without messing with any parasolids. It will push back and forth pretty much in real time. It takes about 30 seconds for it to basically crunch it from one end to the other. But what you're seeing in here is basically a design that can be pushed back and forth. What does that mean? So if you want, prior to the printed circuit board people routing anything, you can try it in your enclosure. If it doesn't work, you need to move components. You can readily move those components and push it back over to the electrical side into SolidWorks PCB. And you can continue to collaborate like this until everybody's cool with the placement. Once the placement's done, then they can continue with their routing and basically get this packaged up and ready for manufacturing. That's the capability that SolidWorks PCB brings to the table. So what if you don't have an electrical staff? Well, hopefully that's where we can help you. That's what we do here at 9.Connects. So we basically do three things. We do services, we do products, and we do training, all centered around the printed circuit board. So what can we do for services? We can start from the bare bones napkin, right? Somebody who's just come up with this really cool idea. They really don't know a whole lot about how it's going to work electrically, but they've got an idea from a systems point of view. We can help them turn that into a real design. Or maybe you already have the design and now you want to get it into a printed circuit board. We can assist with that as well. And sometimes you can get to things where, yes, you're doing printed circuit boards, but now we're doing Bluetooth, or now we're doing Wi-Fi. Now we're doing some type of RF thing which you're not comfortable with. We can get involved with that as well. So that's what we can provide in terms of services. In terms of our products, what do we sell? Well, the two things you might be most interested in is the SolidWorks PCB, which we've referred to earlier here. The second one we also sell is we sell the one that's called the SolidWorks connector. This is for those people who use Altium Designer, which is really a wildly popular printed circuit board tool. And they're gaining momentum all the time. So if they happen to already have Altium Designer and you're already using SolidWorks, we have that ability to have Altium and SolidWorks CAD basically interface with each other in a very similar fashion to SolidWorks PCB. We also sell another number of other what I'll call PCB related products. I will not bore you with those. We can always have that discussion later. Those are the only two products we sell. Anything that's mechanical or any of the other products basically from SolidWorks, you would purchase those through TPM. We do not sell those. We also provide trainings as well. So if you do purchase SolidWorks PCB, more than happy to train you on it. But more importantly, the one we want to point you to is this one called PCB Foundations. As I alluded to earlier, none of us are trained in printed circuit boards. It's all on-the-job learning, and it's usually the University of Hard Knocks that we learn from. So the idea of the PCB Foundations is really for anyone, and we mean anyone. We're talking about not just the engineers. We're talking about the technicians, the program managers, even the purchasing agents, mechanical engineers, anyone who has to or wants to understand the printed circuit board flow. So we're not teaching circuit design. What we're teaching is the flow of the printed circuit board from the design into manufacturing, because as we have learned and as we've experienced with our customers time and time again, if you do not control the printed circuit board design process, it will control you, and it's not pretty. So we want people to understand that process. We don't know of really any other trainings out there that do this type of process training, and that's why we make it available. So if you're interested in that, please certainly let us know. So we were given a small period of time here to present ourselves here. There's so much to cover, very little time to cover it all. So if you're interested in what we've got here, feel free to visit us. It's 9.connects.com. And in particular, if you want to know about our SolidWorks products, it'll be /SolidWorks-PCB. And then you can see all the things that we've got posted there. So that is our presentation, and we'll open it to any questions.